Welcome to an excellent video to get head start on vectors and keep ahead of competition. Here is a class with one of my brilliant student Akshit. Understand what are vectors, how do we add them, what are unit vectors and liked operations. You can always join my classes by sending an email on the address given. Let us enjoy the journey of success with Akshit. Hi Akshit, how are you doing?
Hi, sir. I'm doing well. How are you?
Very good, very good. So, how's your calculus?
It was pretty well, sir. I actually enjoyed the introduction to calculus. In fact, I thought it would be much more complicated, but I realized that it was just a combination of whatever I learned from the ninth grade.
That's so true. So now you are up to vectors, correct?
Right. Yeah.
Ready to begin with vectors now?
Yes, sir. I'm excited.
Correct. So you've done a bit of vectors in physics, correct?
Correct. Yeah.
So you have some idea. I'll add the mathematical component to what you know, so that bridge the gap between what you need to know to do vectors in your curriculum of calculus and vectors. Is it okay?
Yes, sir.
So let me share with you a whiteboard. We'll begin with some small questions, simple questions, and then we'll move on. So, Akshit, can you tell me what are vectors?
Yes, sir. Vectors are basically arrows that have direction and magnitude.
Right. So two important components.
Yeah.
One is direction and the other one is magnitude, right?
Right.
Perfect. So if it is not a vector, then what is it?
A scalar, sir.
Scalar. Okay, scalar. So scalar only has magnitude, right?
Right.
Let's begin with some examples. Can you tell me 4 examples of vectors and 4 examples of scalars?
Yes, sir. Scalars can be like time, weight, temperature, anything that doesn't have like a fixed direction.
So out of these, one of them is wrong for you. You know that.
Oh,
weight
right.
Has
weight.
direction.
Oh,
so
yeah.
Weight will go in vectors.
Okay. Yeah.
Right. Since weight is the force with which the body is attracted towards the center of the earth. You get the idea.
Correct.
So weight has a direction which normally is downward direction.
Downwards.
The gravitational pull gives the weight.
Yeah.
So what comes here actually is mass.
Oh, okay. Yeah. They're both different, right, sir?
The matter contained in a body, it remains exactly same, and that is the mass, correct? So that is very good example. Fortunately, you just casually said something, but it's a very important example from test point of view, right?
Correct. Yeah.
Now, distance. Will you consider distance as scalar or vector?
I'd consider it as scalar, sir.
You're right. So distance is scalar.
Yeah.
And over here we have displacement.
Right.
So that is how they are. Time and temperature are considered to be scalar quantities. See, the temperature could be positive or negative. Still, why do you say that it is a scalar quantity?
Sir.
Right? You could have minus 10 degrees, plus 10 degrees.
Sir, your voice froze.
Okay. So are you able to listen to me now?
Yes, sir, I can hear you now. Yeah.
Okay. So temperature could be positive or negative. Why do you think it is a scalar quantity and not a vector quantity?
Sir, I was thinking that even though it can be plus or minus, right? Even the minus represents the magnitude, right? So I was thinking about it like that. Yeah.
It's just a reference point, correct?
Right, exactly.
You put 0 somewhere, and on the left side, they have minus numbers, on the right side, negative, positive numbers. But still, it is a scalar quantity. It doesn't give you any direction in which it is, right? So that part is correct. Temperature is correct. Mass is correct. And the other component like velocity, acceleration, force.
Yeah, force. Yeah.
So work done, is work done a scalar quantity or vector quantity?
Sir, work done would be vector, right?
So work done is a scalar quantity.
Oh, okay.
Because work done does not have any direction. It just has a
Right.
magnitude. This
Oh, okay.
quantum of work has been done. It's very important to
Okay.
understand. The vector quantity will be torque, which will have
For yeah.
direction. Because when you rotate something like this and then it moves
Yeah.
up, right? So like you have a rule, right hand rule,
Yeah.
which gives you the direction in which the body moves. You get the idea.
Right. Yeah.
So that is the kind of difference. And so these are a few things which we should understand before we move along. And that relates
Yeah.
to many applications which we will be venturing into, right? So this part is clear.
Yeah.
Okay.
Yes, sir. Clear.
Now, let's talk about vectors in details. How do we represent vectors?
Yeah.
So if I have a vector, let's say I want to represent displacement.
Yeah.
Of 5 centimeters north.
Yeah.
How will I do that?
So you can make an arrow that's pointing upward, right?
Right. So we say, well, this is my arrow, which is pointing towards the north. So on a Cartesian plane, we could take north going upwards and east towards right hand side. So that is a component which shows. So the magnitude is represented by the length of this arrow, right?
Of this arrow, right?
So this gives you the magnitude.
Yeah.
And the arrow gives you the direction, correct?
Correct.
Let us say you go 5 centimeters. I mean, a body moves 5 centimeters north.
Yeah.
Then it moves, let's say, 8 centimeters east.
Right.
Then what is the net displacement?
So you can use Pythagorean theorem, right? 5 squared plus 8 squared square root.
Correct.
Yeah.
And then you get, this was 5 for you, and therefore you know the magnitude, right? So let's say the object starts from O, and goes to the position A and then finally to B, right?
Right.
So it reaches B, and we know this O to B is your final displacement. So what is the magnitude of OB?
So the magnitude of OB would be the square root of 89, right?
5 square plus 8 square squared.
Yeah.
Which you say correctly, 25 plus 64. Square root of 89, correct? Now the thing is, we know it is a vector quantity. What is the direction in which it went? So what is the direction?
Right. So there would be an angle involved, right?
Yeah. So how much is that angle, and how do you measure that angle?
In this case, we're given the opposite and adjacent side, right? So we can use the tan.
Tan here. So let me just drop a perpendicular here, because this angle and this angle is same, right? Let's say this is angle theta. So the angle you could give with respect to north, or you could give with respect to east. You get the idea.
East, correct.
How we have to give the angle, right? So as you're saying, this is kind of 5 over 8, right? So we have tan theta equals to 5 over 8.
Yeah.
Therefore, theta is tan inverse of 5 over 8.
Yeah.
Can you please calculate the angle in degrees?
Yes, sir. It is approximately, oh, sorry, I think I'm in
degrees. Do it in degrees.
Yeah.
Easier. Yeah.
It's approximately 32, sir.
Let us say it is 32 degrees, right? So we found this to be 32 degrees, right?
Yeah.
Now this angle we know, and we say final displacement is what?
So it would be square root of 89.
Is square root of 89 units centimeters. In which direction?
East 32 north, right?
Very good. So from east, 32 degrees north. So this is one way of saying the direction. You get the idea?
Yeah.
From east, 32 degrees. Now we could also give this angle from north itself. So how many degrees from north?
So it would be 90 minus 32. Right?
90 minus 32, right? So 90 minus 32, do it. How much do we get?
58, sir.
So we could do from north, 90 minus 32, which is 58
Yeah.
degrees east, right? So
Right.
we can also write it in this particular fashion. Okay?
Right.
Now, whenever we are doing navigation, we normally use bearing angle.
Yeah.
Bearing angles are always from north. Let me just give you this concept also of bearing angle.
Yeah.
So at what bearing is this body moving? O to B.
So it would be
At,
58, right?
we write it in 058, always 3 degrees.
Oh, okay. Okay.
So
Yeah.
at a bearing of 58, the displacement is square root 89.
Right.
Does it make sense to you?
Yes, sir. Clear.
Okay. So in this particular example, what we have seen is, in a way, addition of vectors also. Because
Yeah.
the vector moved in one direction, then into the other direction. And finally, we had the displacement, the net displacement. And
Right.
displacement has magnitude as well as the direction. And we could provide the direction in many different ways. So one is bearing angle whenever you do it from north. Is that clear to you?
Yes, sir.
Let's take another example. This was simple example where the angle was 90 degrees. Straight away, we applied tan theta, the primary trigonometric ratios, and got our result. Let's take second example.
Yeah.
This time, let us say that there are two particles, and let's say we want to add their displacements, right? So we want to add these two vectors. One is going in this particular direction. We'll call this vector as u, and the magnitude of u will write something like, let's say 4 magnitude, right? I'm only writing 4. And it is going east.
Okay.
The other vector is u. Other vectors v. And vectors are normally written with a bar on the top. So they indicate that they are vectors. They are both magnitude and direction. And let us say the angle between these two is 30 degrees.
Yeah.
The angle between v and u is 30 degrees, correct?
Correct.
If I want to add these two vectors, like last time we added the two vectors to get the resultant, right?
Yeah.
In this case, if I want to add the two vectors, then how do we add them? This is what let's look into now, right? Add. To add vectors, what we do is we place the other one of the vectors as on the other, the head of the vector and the tail of the vector matches. So this, whenever we have a vector, this position is called the tail.
Right.
And this position is called the head.
Yeah.
You should also remember that if we have two vectors which are kind of like this, parallel.
Yeah.
Parallel vectors, right? So we are saying these are parallel. And if their magnitudes are same, let's say magnitudes are both are 6 and 6, then their position doesn't change. They're same equal.
Yeah.
They're equal vectors since their magnitude is same and their direction is also same, correct?
Right.
So it is important to understand that the vectors are same, they could have different positions. So what we realize here, equal vectors, different position doesn't matter, right?
Yeah.
It doesn't matter on the position. So now if I want to add v to u, the process is I could actually draw this vector at end of u. You see that?
Okay. Yeah.
So we draw a parallel line to this. So it is also vector v because both are parallel and both are same magnitude.
Yeah.
So you can imagine that you went first along u direction and then along v, correct? That is the computation of the path. And now the resultant will be from initial to final, what is the difference? So that initial is your sum of these two vectors, u plus v. So always when we talk about sum of vectors, what we really do is we place on the head of the first vector, we'll place the tail of the other, and then you could actually add more than two vectors, right? Just follow the process. Now, we know that vector v is at 30 degrees to vector u. Can
Yeah.
you tell me what is the magnitude of u plus v? How will you
Yes,
calculate
sir.
that? Yes.
So we're given that u is 4, right?
Okay, u is magnitude is 4, and let's say v magnitude is, let's say 3.
Okay, yeah.
Yeah.
So, sir, we're also given the angle like it's 30, right?
Yeah. So
And
this is 4, this is 3. Yeah.
so since we cut the 30 in half, right? Would it be 15, sir?
It is not half. It is not half.
Oh, okay.
Because you don't know what that angle. We have to find that angle in a
Yeah.
way. Because
Yeah.
resultant and direction, we have to write down our answer. Angle with reference to u, correct?
Okay, so sir, we can use cosine law then. in this
Cosine
case,
law.
right?
So what is this angle tell me?
Right. So we can label 4 as side A and 3 as side B, right, sir? And then
Yeah.
the opposite one as side C.
This angle will be 30, right?
Yeah, 30.
Because v is at 30 degrees to u. But do you see that? And therefore, that angle will be 180 minus 30, which is 150 degrees, correct?
150. Yeah.
Is that clear to you? So you
Clear.
have to do 180 minus theta to get the angle between the two vectors when you
Yeah.
are adding them. That's important. Sometimes students just put 30 there in between, which is the wrong answer. Is that okay?
Yeah.
So now you can tell me this magnitude is equal to what? Square root of a square plus b square, right? Which is 4
Yeah.
square, correct? Plus b square, which is 3 square,
3 square.
minus 2 times ab
12. Yeah.
cos of the angle 150. Is it okay?
Yes, sir.
Can you calculate this?
Yeah.
You can use special triangles and also calculate. You can do that. But
Yes, sir. Sir, I got approximately 6.76.
Yeah, because see, cos of 150 is a negative quantity, right?
Negative.
So it will become
Yeah.
positive cos 30 basically. You understand?
Yes, sir. Yeah.
Right. So all of them will get added up and then you do square root, correct?
Right.
So what do you get as the magnitude?
6.76.
6.76, right? So that becomes the
Yeah.
magnitude of u and v, correct?
Correct.
Now, once we know this magnitude, what is the direction? Can you tell me? So when you have to give the direction, give it with reference to one of these vectors. Then normally we'll take the
Yeah.
horizontal one. So
Okay.
tell me, what is this? How much is this angle? How will you figure this out?
So we can use sine law now, right? To find the angle.
We can use that. Yes, we can. So you know the magnitude. So you'll use u plus v, which is 6.76.
Yeah.
We want to find angle. Let me put angle on the top. So let's say this angle is theta, right? So we'll say
Yeah.
sine theta over the side opposite is 3 should be equal to sine of 150 degrees
Yeah.
over 6.76, right?
Right.
So from here, what is theta? Theta is sine inverse of 3 times sine of 150 degrees
Yeah.
divided by 6.76. How much you get?
12.82.
Degrees, right?
Yes, sir. Degrees.
12.82?
82. Yeah.
So let's say 80. So that angle is 12.8. And therefore,
Right.
what is the vector sum of u and v? We can say that the sum is 6.76 and the direction is from u, right? It is at
From you.
12.8 degrees from u, right?
Right.
Vector. Is that clear?
Sir?
Yes.
Sir, instead of writing from you, can I also say east 12.8 degrees north?
No,
Would that
I
be-
never said that u is east.
Oh, okay.
I only
Okay.
relatively told you that the vectors u and v are at an angle of 30 degrees. Now, you could be east, it could be north, south, right? So do not
Okay.
assume it to be east, right? Since
Sir, but isn't it written east?
No,
If
no.
it's east,
Oh, I wrote east. Oh, I see, I see.
yeah.
Yeah, if I wrote east, yeah, I forgot that. Then you should say
Okay.
from east, no problem. right?
Okay. Yeah.
But if my question was, let me give you the question, right? So we are not
Yeah.
talking about two vectors, u and v, right? So vector u is, let us say the magnitude is, let me take 3, yeah? And
Yeah.
vector v, the magnitude is, let's say 4, right? Simple, because we know we get 5.
Right.
Easy answer.
Yeah.
The idea is, and the angle between u and v. So vectors is always written with a bar, is
Yeah.
equal to, let us say, 60 degrees.
Right.
In that case, this time, I would like you to find what is the difference between the magnitude, what is u minus v?
Yeah.
How will you do that? Let's try to understand difference of vectors now.
Yes, sir.
So how will you do difference? So we are not saying that u is along east this time, right?
Yeah.
But we are saying u and v has a direction of 60 degrees. So basically, if this is u, which is
Yeah.
unit 3, then v is at an angle of 60 degrees. Is that okay?
Yes, sir.
And the angle between them is 60 degrees. This is what we are saying, correct?
Correct.
And on this side, we have vector u. And both magnitudes we know is 3 and 4. Okay. Now, when I say difference, u minus v, so we have to now sketch a vector, which is, if I sketch this vector here, do you see that?
Yeah.
Then it becomes same direction. Do you see that? So
Same
we have
direction.
to add, basically, this is same as adding to u negative v. Do you see?
Negative v. Yeah.
So what is the negative of v?
Yeah.
Negative of v is the opposite vector, which is also called same magnitude, but the direction reverses. You get
Different direction. Yeah.
So instead of going this side, it will be coming this side. Do you see that?
Yes,
So
sir.
that is negative v. You see that?
Yeah.
So you started with the origin, let's say O here, and that is what you have. And in that
Yeah.
case, the resultant will be from here to there. Do you see that?
Yes, sir.
So this now becomes u minus v, which you're looking into, right?
Right.
Now, can you tell me what is the magnitude of u minus v? So first we'll calculate magnitude of u minus v using cosine law, just as
Yeah.
we did earlier. So now then, what is this angle?
So that would also be 60, right?
Perfect. Because, when you extend, this is 60 degrees, and vertically opposite will be 60 degrees. So not 180 minus 60.
Right.
So this time it is 60 degrees, and therefore the expression now will be u square plus v square minus 2uv cos of 60 degrees. Do you see
60.
that?
Yeah.
So that's, you can always calculate and get me this answer, not a problem, right? You can always do that. So can you just calculate? We'll just plug in the values. So it is u square is, let's say, 9 plus 16 minus 2 times 12, which is 24, and cos of 60 degrees is half, right?
Yeah.
So that will be how much? So half is 12, so 4 plus 9 square root 13, right?
Yeah, root of 13.
Right. So we get the magnitude of u minus v as square root of 13.
13. Yeah.
Now, sometimes my question will be, find a unit vector.
Yeah.
In the direction of u minus v. Find the unit vector. So I'm introducing you to another term, which is called unit vector. Unit vector means what? Unit vector means magnitude is 1.
Oh, okay.
So this vector is square root 13. So we'll divide u minus v by 13 to get a unit vector in that direction. You get the idea?
Oh, okay. Yeah.
Okay, so that's one. Now, definitely, when we've done all this, let's also find the direction which v makes with u. U minus v makes with u. Can you find this direction? This is
yes, sir.
Yes. So it is again, v was 4 for us, right? So sine theta over 4 is equal to 2. And u minus v is, we found how much? Square root 13, right?
Yeah.
Sine of 60
over square root 13.
So find theta.
Yeah.
How much you get?
73.9.
So we have solved this particular question by giving both magnitude and direction, and we know this is it, right? But in case you want a unit vector in this direction, we'll just multiply u over v by the magnitude of u over v to get 1 as a magnitude. Is that clear to you?
Right. Yeah.
Okay. So that is a brief introduction on vectors as such. So now let's kind of put these vectors on a coordinate plane and do the same thing, right? So let's say this is our coordinate plane.
Yeah.
So in coordinate plane, we have x-axis and the y-axis.
Right.
So a vector could also be represented on a coordinate plane where any vector in the direction of x is represented in terms of I, where I is a unit vector in direction of x and j is a unit vector in direction of y. So what is I? We normally write this I as with a cap. So this means unit vector in x direction. And j means unit vector
in y direction.
So I could write a vector u as, let us say, 3i plus 4j. You get the idea.
Yeah.
If I say a vector is 3i, 4j, it means a combination of two components where I is 3 times this length, 1, 2, and 3. You see that?
Yeah.
And 4j means 1, 2, 3, 4. You see that?
Yeah.
And so we're talking about a vector which is indeed this.
Right.
That is the vector we are calling 3i, 4j. You get the idea? Sometimes we write this vector as 3, 4. In this it means 3i, 4j.
So ij, right?
So it's not exactly a coordinate point. But in many books, we also write this with square. We say 3, 4, right?
3, 4, right.
Which also represents the same vector, 3i, 4j, right? So,
correct.
So it could be represented in many different ways. You get the idea?
Yes, sir.
Now, for this vector, u, which is 3i, 4j, can you please find the magnitude of this vector?
Yes, sir. It would be 5.
5. You just do square root and then it is 5. And what is the direction of this vector? That means with x-axis, what is the direction of theta?
So, sir, we would have to use the tan ratio again, right?
Tan ratio again, right? So 4 over 3, right?
Right. Roughly 53.1 degrees, sir.
Yeah. So that becomes the angle between this. Now, if I want you to write down a unit vector, in direction of u, tell me, what is the unit vector in direction of u?
Right. So, sir, you said the unit vector must only have a magnitude of 1, right?
Correct.
So if our u vector is 5, then we would have to divide by 5, right, to get.
All right. So the unit vector, which I'll write as a cap here, right? Will be what? 1/5 of 3i plus 4j. You understand?
Plus 4j, right.
So basically, you could also write this as 3 over 5i plus 4 over 5j, right? In many books, it would also be written as 3 over 5 and 4 over 5. Is that clear to you? So
yes, sir.
This vector is a unit vector whose magnitude is 1, correct?
1.
A square plus b square square root is going to be 1. So now is that concept clear to you?
Yes, sir. Clear.
So unit vector really helps us. For example, I could now say, find a vector in the direction of u whose magnitude is 7, right?
Right.
So let's say vector v is 7 times the unit vector. So what is the value of v? Vector v. 7 times 7 magnitude of 7 in u direction. You understand?
Right.
So what will be that vector?
So, sir, would it be 7 times 3i plus 4j?
Yes. You see that?
Yeah.
So that will be 7 times 3, 21 over 5, and 7 times 4, 28 over 5. Do you see that? So this vector now becomes a vector with a magnitude of 7, but in the same direction as u. You get the idea?
The u, yeah.
So on a Cartesian plane, we have seen how we could represent vectors, how we can find a unit vector. Finding unit vector is giving us a flexibility of representing any other vector with magnitude different from the given magnitude, correct?
Right.
It could be in the negative direction also. We could also say, we'll also look into examples where it could be parallel to it and positioned somewhere else, or it could be perpendicular to the unit vector, right?
Yeah.
So at this moment, when I've drawn this diagram with the vectors fixed at the origin, we have a very special name for these vectors, and they are called position vectors.
Oh, okay. Position vectors. Yeah.
So whenever I say position vectors, it means that the tail is on the origin.
Origin, yeah.
So we have fixed their position. You get the idea.
Right.
So whenever you have any vector whose tail is on the origin, we know it, we can call this as a position vector. It helps us to give a frame, right? Reference frame, where they are exactly. Since we also understand that the vectors, when we say they only have magnitude and direction, their position is not fixed. They could be anywhere, right?
Yeah.
So whenever we are trying to add u and v, we put the other vector on the, we combine head and tail, right? And then do our operation on them. So normally what we do is we try to put them all at the origin. It just becomes very easy for us. So vectors could be here, there, everywhere. Put all the vectors at the origin. You can once they are all at the origin, then you can work with them and then find the resultant of the vectors very easily.
Right.
So getting to that point, let's end with the last example here. So what I will do here is that, let me clear this. Everything is clear so far?
Yes, sir. Everything is clear.
So let me have 3 vectors. And what I will do here is that I'll just make all the 3 vectors, pull them to the origin, right? Let's say one of the vectors is kind of like this. One of the vectors is kind of like this.
Yeah.
One of the vectors, let's take simple like this.
Okay.
So we could write this vector as, let's say 5 and let's say 3.
Yeah.
Let's write this vector as minus, because this is x value is minus, right?
Right.
Minus 4, and let's go up by some units. So let's go up by 3. Let's say 3, doesn't matter. And this vector, we know x value didn't really change. So x value is 0. And the y value is, let us say, minus 1.
Correct.
So we have these 3 vectors, u, v, and w.
Yeah.
Now tell me, what is the sum of these vectors? U plus v plus w. How will you do that?
Okay, sir. So we can represent each, I can say numerator as with the variable I, right? And then each of the bottoms with j, and just add all the i's and add all the j's.
Add all the i's and add all the j's. You're right.
Yeah.
So basically, writing this really helps, right? So we have 5, 3, right? Basically, plus minus 4,
minus 4,
plus 0, minus 1. You get, see how easy it becomes, the vector operation?
Yes, sir.
So 5 minus 4 is 1, and 3 and 3 is 6, minus 1 is
minus
5.
1.
You see the
5.
sum, right? So that is my vector. So let's say the vector is p, right? Let's say p. Right? So the vector p is 1, 5. It really means I'm writing I plus 5j.
5j.
Get the idea, right?
Right.
What is the magnitude and direction of this vector? Can you tell me?
Yes, sir. So
magnitude
it would just be
p is what? 1 square plus 5 square square root. Do you see
square rooted? Right. Yeah.
26 square root. Is that clear to you?
Yeah.
And what is the direction? So we'll say tan theta is the ratio of y over x, right?
Right.
So which is 5. And so theta equals to tan inverse of 5, correct?
5. Yeah.
You can find the answer using the calculator. Figure this out?
Sir, it comes out to 79 approximately.
79 degrees. That really means I could really sketch the end product so easily. Do you see that? So
Yeah.
79 degrees, let's say this is my 79 degrees, and on that,
Right.
I'm looking for a magnitude of square root 26, which is
26.
around 5, right? Do you see that?
Yeah.
So let's say this. Okay. So that is my vector P.
Right.
Sum of all the three vectors. You get the idea?
Yeah.
So the vector operation really helps us to, especially when we write in Cartesian quadrants as given
Yeah.
here, or in this column form, right? It's also called the
Right.
column form. So we have row or column, any form can be used, right? So this is column.
Okay. Yeah.
We could use the row also, right? But this column form is very easy to work with, as you've
Yeah,
just
it is.
seen.
Right.
And easily you could add the vectors and get an idea of what their resultant is. So when we say sum,
Yeah.
kind of resultant. So with that, we've actually done a very important physics problem. We could have
Yeah.
had this question by saying that there are three forces. Do you see that?
Yeah, three forces. Yeah.
Acting at a point.
Right.
Like a tug of war kind of thing, right?
Exactly.
What is the
Yeah.
resultant force? What is the resultant force? So we just found P is our resultant force, and that is how we could calculate
Yeah.
so easily, right? So vectors give us an edge over many other processes and procedures.
Yeah.
Mathematically, we can calculate, many physical things using
Yeah.
vectors very easily. It gives you a
Right.
look also how it is to be done. Is that clear to you?
Yes, sir.
So we'll end our lesson today here. I'd like Akshat you to summarize what we have learned.
Yes, sir, for sure.
Yes, tell me.
So, sir, I was actually introduced to vectors in grade 11, right? And then we like revamped on it in grade 12. So I actually initially forgot a little bit about it, right? But today's lesson really brought back what the difference between a vector is and what a scalar is, right? And just in like a short amount of time, I like remembered how to add vectors, subtract vectors. And of course, I got introduced to a new concept of the unit vector and the variables I and j. So I think now I'm definitely ahead of the class because we haven't even started vectors yet. So I'm pretty happy about that.
Great. So we'll look into application of vectors in the next class,
Yeah.
where we will see exactly how different forces acting at a point will affect that particular point, or what is going to be the net force or the resultant force, right? So we'll look at many physics questions in the next class. Is that okay?
Yes, sir.
Okay, then. Great. Thank you, and all the best.
Thank you so much, sir. Have a good day.